All right, ladies and gentlemen, in this video we are continuing, of course, our geometry fun here today. We spent a lot of time talking about parallel lines in the past few videos, in the past few units, and today we're going to be opening up our discussion topic of perpendicular lines. Now, as a whole for this next upcoming unit, the goal will be able to find the distance from a point to a line in a coordinate plane and use some new theorems regarding perpendicular lines to prove some different mathematical statements, but also be able to really draw some conclusions about certain figures. But for this video specifically, we're going to be focusing on the success criteria in which we need to know and we need to be able to define what a perpendicular bisector is and go ahead and find the distance from a point to a line. So let's take a look here first and foremost at a perpendicular bisector. Now, a perpendicular bisector, and what we'll have after this video is a video that will help us construct a perpendicular bisector. But before we get there, let's define perpendicular bisector. Well, first and foremost, to be perpendicular means two lines intersect in such a way that they form a right angle. So that's one part of our phrase. The second part is that term bisector. Bisector just simply meaning cut something in half. To bisect it means to cut in half. Bi meaning two, right? And so right now we are thinking a perpendicular bisector is some line or segment that is both perpendicular to it and it passes through the midpoint. That's the bisecting part of things. So what does it create? Well, think about what the perpendicular bisector creates. This is important. This is important. It creates two things. It creates one perpendicular line to another, and then it creates two congruent segments on opposite sides of the midpoint. So there's a couple different ways that you may see this just in general. You may get an opportunity to where it says, hey, if this angle has a value of 9x minus, 9x minus 9, you know that because it's a perpendicular bisector, if they wanted you to solve for x, well then 9x minus 9 would equal 90. You could add x 9 on over, and of course we would see that x in this case would be 11. So maybe that's one way that they would have us use perpendicular bisector. Or what if they maybe said, hey, it's a perpendicular bisector, and so if this is 2x plus 2 and this is x minus 4, use what you know about a perpendicular bisector to find the value of x. Or maybe what if they said find the value of PM? What if they wanted to know the value of PM? Well, since it's a perpendicular bisector, 2x plus 2 would equal x minus 4. So if I subtracted a x on both sides, I would have x equals, and subtracting 2, it would equal negative 6 in this case. Now again, please keep in mind here, I completely just made up these numbers here. So x being negative 6 probably wasn't the best choice, but this is just kind of a realize of how we could utilize the perpendicular bisector. The other concept that comes into play when we are talking about perpendicular bisectors is just the concept of a notion of the distance from a point to a line. The distance from a point to a line. Now let's think about this here for a sec. When we think of back just in life in general, you've probably heard the phrase, what's the shortest distance from point A to point B? And most people would say, well, it's a straight line. And I'm not saying they're wrong, but I'm not saying that they're 100% right. So let's say, for instance, all right, you're sitting watching this video, maybe in your bedroom, and you're sitting at your desk and there's a wall behind you. So if you are sitting right here at your desk, so there's a chair, and you are sitting at your desk, watching it, right? And there's a wall that is behind you. All right. So the question is, what's the shortest distance from you to the wall? If you just described to me a straight line, my question to you is it this straight line? 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 Which straight line is the shortest distance to the wall? And then most of the time, the students respond in a sense of just go straight back. Well, what does straight back really mean? Now we're getting deep into our geometry. Now, that concept that you're thinking of just going straight back, that is the specific segment that is not only straight, but it is perpendicular to the line, aka the wall that you were trying to get to. So when we see situations like I have here on the screen, what we end up seeing is we have three pathways. And the question is, find the distance from a point to a line, point A to the line. Well, point A goes to line BC in three different pathways, but I only care about one of them if I'm finding the distance from the point to the line in general. Now, if that's the case, I'm looking for the distance from the A, the point, to its perpendicular segment to the line. So what I'm really trying to focus on here is finding the distance of, in this case, AC. And our distance formula is x2 minus x1 squared. So x2 is 1 minus a -3 is a +3 squared plus y2 minus y1 squared, which is -1 plus 3 squared as well. So we get 1 plus 3, which is 4 squared. 4 squared. And -1 plus 3, which is 2 squared. So we get 16 plus 4, all under that square root, for a square root of 20. Now, depending on what the question says, it does not say round to the nearest anything here. So usually if that's the case, I'm going to go ahead and try to keep it as exact as possible. So I'm going to go ahead and simplify this radical. So remember correctly, I'm just going to put a little arrow up here. Remember, square root of 20 can also be thought of as the square root of 4 times 5, right? Because 4 times 5 is 20. Why am I choosing 4 and 5? Because when you're simplifying radicals, you want to find the highest perfect square factor, which in 20 is 4. So if square root of 4 times 5 also is 20, I take the perfect square of 4, which is 2, and I bring that on the outside. And so my final answer is 2 root 5. And again, if you don't believe me that this works, in your calculator, do square root of 20, and then do square root of 5, and then times it by 2, and see what happens. You get the same answer regardless. Why don't you go ahead and give number 4 that's on the board here a shot on your own for some additional practice.